Okay, so in these 4 problems, we're asked to evaluate the limits and then talk about the graphical implications. Evaluate. And what does that mean for the graphs? Okay, so the first thing we need to notice is we're talking about what happens when x goes to infinity. So these are talking about horizontal asymptotes as x goes to infinity. Positive infinity, so that's far off to the right side of the graph. Negative infinity would be far off to the left side of the graph. But basically, what's happening with your horizontal asymptotes? Are the y values approaching any certain number? Asymptote. So there are 3 different things that we can look at when we're talking about horizontal asymptotes. Is your graph bottom heavy? Is your graph top heavy? Or is your graph neutral? And each of these 3 give you a different type of horizontal asymptote. That says neutral, and this says top heavy. So if your graph is bottom heavy, we're always going to have y equals 0 as a horizontal asymptote. Okay, the values on the bottom of your graph will be so much larger than the values on top that essentially you're going to be going to 0. The fractions will be so small. If it's neutral, then we're looking at the coefficients. So the y-intercept will be some other type of a number other than 0. And if it's top heavy, we're not going to have a horizontal asymptote at all. You're going to, in fact, have an oblique asymptote, normally a linear one that you can find using long division. So in each of these first 3 problems, we notice that they are limits as x goes to infinity. So these are all asking for horizontal, oh, not that one, these first 2. So we need to evaluate. On top we have an x squared, and on the bottom we have an x squared, which means we have a neutrally weighted equation. So we look at the the coefficients. So we have a -1 coefficient on top and a +3 coefficient on the bottom. So the limit is basically going to be -1/3. Which means you're going to have a horizontal asymptote at y equals -1/3. Okay, for 18, we notice we have a linear equation on top and a quadratic on the bottom, or a 5th degree, whatever that happens to be, I can't really tell, which is definitely bottom heavy. Okay, a power of 5 is way much more than a power of 2, so it's going to be something over something big, 0 over a number, which is basically going to be 0. So we're going to have a horizontal asymptote at y equals 0. Now notice on these other 3, they're not going to 0, but the limits are going towards a number. So here we have a limit as x goes to 3, and here we have a limit as x goes to +3 as well. So these are looking at whether they are vertical asymptotes, potentially, ASY, or maybe they're going to be a whole, or maybe it's just going to be a number. Okay, it's perfectly fine for the limit to go to a certain number. That's what the graph approaches from the left and from the right. So if we have a vertical asymptote, we're going to have some like a number over 0. Okay, something that will be undefined. When you plug in the value, you're going to have a number on top and 0 on the bottom. For a whole, you're going to have 0 over 0. Okay, something that's completely undefined, both top and bottom. And at the point, it's just going to be a number. It could be 0, 0 over a number. Lots of different options to actually have a point. So let's plug in the number 3. we get 2 times 3 minus 6 over 3 squared plus 9, which is 6 minus 6, 0. 0 over 18, which is 0. Okay, perfectly fine to have 0 as an answer. This means that we have an x-intercept. That's what happens at 3 for this graph. An x-intercepts at the point 3, 0. Okay, if this were any number other than 0, it wouldn't be an intercept. It would just be a random point out there in space. But because it turns out to be 0, that means we have an x-intercept when x equals 3. That's where this graph will cross the x-axis. Okay, on the bottom here, when we plug in 3, 2 times 3 minus 6 over 3 squared minus 9, we get 0 on top and 0 on bottom. Okay, and if we have 0 on top and bottom, that means we're going to have a hole at 3 comma something, and the question is, what will the y value be where that hole actually occurs? So to do that, we're going to factor these things and cancel. Okay, so this is the algebraic process you would do if you come up with a 0 over 0 when you plug in the limit number. So on top, we can factor this to 2 times x minus 3. And on the bottom, we can factor this to x minus 3 and x plus 3, the factors of this quadratic. Where hopefully you notice the x minus 3's on top and bottom cancel out. And we have a simplified rational function of 2 over x plus 3. So now when you plug 3 in, we have a 2 over 3 plus 3, which is 2 over 6, which reduces to just 1/3. So this is the y value of the hole in our rational function there. Okay, so if you have limits going to infinity, those are talking about horizontal asymptotes. And if you have limits going to a number, they're either vertical asymptotes, they are holes, or they are some type of an intercept or an actual point on your graph.